welcome back. This is mainly a review, so we're going to go through it kind of quickly, but it is a very important review because with our final exam coming up next week, it is going to be something that you're going to want to recall, you're going to want to have, and you're going to want to make sure that you know how to be efficient with, because there are going to be questions pertaining to this type of concept or this problem-solving strategy that you want to master in order to get these test questions right. I'm going to leave the explorations 1 and 2 for you to do as a warm-up tomorrow, and we're going to talk specifically about some of the vocabulary and then some of the core concepts in the notes here before moving on to just a few sample problems, and then we're going to go ahead and finish the video. All right, so the average rate of change, that's going to be the slope of a line that is connecting 2 points on the parabola. So notice that I've gone ahead and drawn a parabola here. I've sketched a graph of one, and then I've drawn a line connecting 2 points on that parabola. I could have picked any 2 points that I wanted to create an average rate of change, and so I've given this as the example. So you can clearly see that I could find the slope of that line by using the slope formula. M equals y2 minus y1 over x2 minus x1. So if you're looking for any average rate of change problems, that's what you're looking for when you're trying to solve those. And this is a concept that I introduced a while ago, and I wanted to just bring back to the front of your mind to help you. This is systems, but solving quadratics by using systems. So this would be an opportunity for you to use the matrix if you're given data. And that, remember, if you're given a quadratic and you're expected to find the regression for it, you have to have 3 points. So that's why there are those 3 equations there. And then you would just plug in your ordered pairs for x and y and leave a, b, and c as your variables, and then you'd solve using the matrix, or if you wanted to, Gaussian elimination to help you refresh on that topic, because I'm sure you all loved it so much the first time around. And so what we're going to do here is we're going to look at the core concepts about writing quadratic equations. So if you are ever given a point and the vertex of the parabola, and you're expected to write a equation from that, then you're going to want to use vertex form, okay? And down here in the notes, you'll notice I've written some things about how to actually find all of the missing parts. And we've done this a little bit also in solving for A after plugging everything in before. So this is something that you're going to want to refresh on also for sure. So you'd want to graph the parabola using H and K as the vertex. And then you could use critical values to graph and see if you could find the stretch that way. If the point was nice enough, you could figure it out. And what I mean by critical values, if you remember, are on a parabola, if I go over 1, up 1, I'll be back on the graph again. But if there's a stretch, then I would go over 1, up 2 instead, and that would represent a stretch of 2. So you could do that. Or what you could do is you could use H and K and the point as X and Y, and you could plug them all in and solve for A. That would leave a lot of the guessing and checking out of it, especially if you didn't feel like the stretch A was a friendly stretch, which sometimes it's not. Now if you're given a point and the x-intercepts, that's going to be your intercept form, where you want to go ahead and do the same thing again, plug in y and then x and p and q and solve for A to find your stretch there. You could use the same idea of graphing it and looking for the stretch, but it's just not as easy as actually solving for it in intercept form. And then, of course, if you're given 3 points, we could use stat edit. That's always the easy one to go to. But because I've introduced the linear equations and the matrix, I'm going to go ahead and follow through with that one more time. So you'd substitute the 3 points into the 3 equations, and then you would use your matrix to solve for A, B, and C. And then, of course, you'd write it in those terms, okay? So these are some ways that you would represent an equation if you're just given a graph or partial information of a quadratic. All right, the one place I want to go to before we end this video is I want to go to 9 through 11. And of course, we're going to do all of these, so it's not like we're skipping over. It's just that a lot of it is review, and I don't feel like I need to go over it with you again. But I want to talk to you specifically about how you know whether or not data is linear, quadratic, or in this case, neither. But I'm going to switch neither to exponential because I realize that this is an exponential regression, and I want to tell you what that actually is. Okay? So if something is quadratic, you talk about the second difference being constant. Okay? And I know that this is a review from Algebra 1, so we're definitely going to dust off those cobwebs and readdress that so you know what you're looking for here. All right, and if it's a linear set of data, then you're looking at the first difference being constant. And then if it's neither, then you're not going to see either of these two things, but I want to take it a step further, and I want to talk about exponential regression, and that being a common ratio, because that's something we're going to see. I'm going to go ahead and preview that so that it's not a brand new concept when we see it next semester. So the first thing you have to do is you have to understand that this must always be the same, and each time it's +1, so that is the same. If these numbers are not the same difference, then we've got a big issue here with using this second difference idea. And so what I'm going to do is I'm going to take the first difference of these two, and I get 8. These two is 40. This 72. This 104. And this 136. Then from there, I'm going to take the constant difference of the second group, and I get 32 here, 32 here, 32 here, and 32 here. And this is what is known as your second difference. And you'll notice that that is constant, and since that's constant, we have a quadratic regression. Now this is in addition to using StatEdit on your calculator, but I want you to understand that there's other ways to find it than just using calculator and technology. All right, again, we have to make sure that this is constant. It doesn't have to be 1, it just has to be constant. So notice that each one of these is +3. And since that's constant, we're good to go on this. This one's going to be 6, and this one is 6. Actually, it's -6, but that's not really the important part here. And this is what is known as your first difference, which makes this a linear regression. And then here, what we're looking at is, again, you've got to identify that the input, the x values are constant, and this time, again, they're all +1, so we're good on that. And now what you're looking for here is you're looking for a common ratio. So if I divided 15 by 5, I'd get 3. 45 by 15, I get 3, so on and so forth. So this common ratio, by using division, and I'll go ahead and put that symbol there, so we can see that I'm using division to get my ratio, because remember, ratios are just fractions. You can see that that common ratio there is 3. If you have a common ratio, then you've got exponential regression. And like I said, that's going to be something that comes up second semester, and so I wanted to make sure that you're looking at that and being able to see that, especially when we come up to it, shouldn't be first thing. So notice I haven't actually answered all of the questions for you. I've just gone ahead and shown you the idea of second, first, and common ratio so that you can see another way of doing this. What I'd like you to do is make sure you go back and solve each one of these to find the actual equation that fits the data. And of course, we're going to spend some time tomorrow in class working on the rest of this worksheet. So bring it with you. Be prepared to share what you have learned, and be prepared to ask questions about the things you're still confused about.